Hi everyone, welcome to my YouTube channel. Today we will be solving the question reverse linked list 2. So in this question we are given a singly linked list. We are given the head of the list and we are given two integers left and right, and we have to reverse the linked list from left to right, both inclusive, and return the output linked list. So let's have a look what we need to do in this problem. So here we have this linked list. We have the head node, we have left value and right value, and the output list would be this. So basically we reverse the sublist from left to right and return this output linked list. So in this question, so basically first we need to clarify some things about the data, about time complexity, space complexity, what is allowed, what is not allowed. And this is really crucial in a coding interview, that we should always ask some clarifying questions before proceeding to write the code for the problem. So the first clarifying question you can ask is, can the linked list have duplicates? So the answer is yes, the linked list can have duplicates, because it won't affect the problem if there are duplicates or not, because the left and right integers are just indexes here, and this is basically one based indexing. If left and right had been the node values, then this question would have been slightly different, and then having duplicates would probably lead to having multiple solutions. So here that's why they have given left and right as indexes, and it wouldn't matter if there are duplicates or not. And also it also does not matter if there are positive or negative integers, as we are not really concerned with the values in the linked list, and we are only concerned about their ordering. And the another constraint is we have to do this question in O of n time and O of 1 space, and we have to use something which is called as single pass. So what single pass means is we have to iterate over the linked list only once. That is, we can only start from the head only once and iterate over the list. That is, let's say we can only have let's say we have a while loop and we start from the head of the linked list, and we don't have another while loop and we are starting again from the head of the linked list. We cannot do that. We can have more than one while loop, but basically we cannot just reset from the head of the linked list. And next clarifying question you can ask is, can we modify the list? So the answer is yes, we can modify the linked list. Generally in linked list problems we need to modify the linked list in order to solve it optimally, and some problems cannot be solved without modifying the linked list. So yeah, we can modify the linked list. So yeah, let's dive into the problem now. So we have our list here, 1 2 3 4 and 5. So, and we have to reverse the sublist from 2 to 4. So how we can approach this problem is, so first we can just focus on reversing this sublist. And what do we need in order to reverse a linked list? We first need the head of the linked list. So here in this case the head is left and the end is right. And previously we covered how to reverse a linked list, and the way we reverse the linked list was by iterating over the linked list, and once we reach the null node, we are done with iterating over the linked list. So here let's focus on our sublist 2 3 and 4. So here if I am going to iterate over this linked list, so currently the end of this linked list is at 4, but 4 dot next is pointing to 5. So here we are going to need to modify this 4 dot next to null, and before we update that we need to store the reference to this node 5. So let's call it next pointer, and before 2 we have our node 1, and after we reverse this linked list, so the ordering is going to change. This is going to become 4, 3 and 2, and we have to attach the new references correctly. So here let's call the node 1 as previous node, and basically we have to update the previous pointer to point to node 4, and the left pointer, original left pointer, to point to node next. So we have to be careful when we are updating the pointers after reversing our sublist. And here when I mentioned this updating to null, so we need this because in order to iterate over the linked list, so we know we are done when we reach the null element. So that's how we know that we have reached the end of the sublist, by reaching the null element. This is similar to iterating over an array where we use indexes, and when the index becomes out of bounds, we know that we have reached the end of the array and traversed it. Alright, so to update the pointers, what's going to happen is this node 4 will be the new head, and currently node 4 is our right index. So since right is integer, we are going to need the actual reference to this node 4. So let's call it right node, and let's call it the node 2 as left node. So these references are going to remain the same after we reverse the sublist, and at the end what we are going to do is we're going to update previous dot next as right node, and we have to update the left node dot next as next. And how do we find these right nodes and left nodes? So to find these right nodes and left nodes, first we're going to have to iterate over our original linked list, and since left and right are indexes, what we can do is we can start by creating an integer. Let's call it index and call it 1, and as we are iterating from the head, we can set the left node and right node. So how we can set the left node and right node? So if we reach the left, we can set the left node, and if we reach right, we can set the right node. And along with setting the left node and right node, we will also have to set the next and previous nodes. So to understand that better, I can explain that better in the code walkthrough. That would be easier to understand. So this was just a simple example for this problem. So let's have a look at another example. So before moving on to next example, let's think about a few things. So here what I did was I updated previous.next, and here I updated left.next. Now you might be wondering, what if I get a null pointer exception? Can I get a null pointer exception here? So with left.next, I cannot get a left pointer exception because left is greater than equal to 1 and left is less than equal to right, and right is less than equal to n. And with previous.next, I can surely get a null pointer exception. So we need to be careful here. So the example which can give a null pointer exception, let's have a look at that. So can draw again the linked list 1, 2, 3, and 4. So let's say if left is 1 and let's say right is 3. So in this case our previous pointer is going to be null, and if we use this logic here, this is going to give us null pointer exception. So in linked list problems, this is a common pattern, and to solve this pattern, what we can do is we use dummy nodes. So using dummy nodes, we can simply so using dummy nodes helps us to write clean code. So we don't need to have special if checks for the previous node, and like our code will cover all the cases if we use the dummy node. So let's create a dummy node and try to understand it. So let's say we have a dummy node and it has value -1. So this dummy node can have any integer value. I'm just using -1, and we have our head, and we have 2, 3, and 4. So here I need to set dummy.next equal to head, which is also left equal to 1. So in this case, when I set the previous pointer while iterating over the list, this will always be not null. And my next is here. And so using dummy node helps us to avoid null pointer exceptions. And the next thing we can think about is, what if the next pointer is null? So let's draw an example in which the next pointer can be null. So we have this linked list again, 3 and 4, and we have our right equal to 4. Let's say left is this. So in this example, while we are iterating over the list, the next pointer is going to end up as null, and we don't really need to worry about null pointer exceptions with the next pointer, because we are not really making references to next in our code. So yeah, we don't need to worry about that. And the next case we can look at is, what if left is equal to right? So in that case, we can simply return the head of the linked list and we will be done. And what to return for other cases in the code? So let's have a look at our original example here. Let's go up. So our original example was this list starting at 1 and ending at 5. Let me draw this again at the bottom. So we have 1, 2, 3, 4, and 5. So the left was 2 and right is 4. So after I reverse the sublist, we have this, and in this case we can just simply return the head at the end of our code and we will be done. So in this case, the head node is not really changed or modified, and we can simply return head. But what if the head is changed? So in what case the head is going to be changed? So now let's have a look at the case where the head of the linked list can change. So here we have this linked list where the head is at 1, dummy node is -1, and dummy.next is head. We have already said that. And let's say our right pointer is at 3, and the case where the left pointer is at head, the where left is equal to 1. So in that case, the head of the output linked list is always going to change, and this is for the case when left is less than right. For all of these cases, the head of the output linked list is going to change. So for this case, what is going to be the output linked list? The output linked list, it's going to be 3, 2, 1 and 4. So here we have this output linked list, and here we cannot simply return the head, because the head of the original linked list would come here, which is the third node of the output linked list, and this is basically the new head. So how to identify the new head? How to identify head of output linked list? So in this example, let's draw it again. So we have -1, 1, 2, 3 and 4. Our right is equal to 3, our left is equal to 1, our dummy is node -1. So here, since left is this, so the previous would be equal to dummy node, and next would be our node 4. So when I'm going to update the previous dot next pointer after reversing this sublist, so after reversing this sublist, it's going to be, the pointers would be reversed, and now I can update my previous dot next. So it's going to be pointing at 3, and my left dot next, it's going to point to my next node. So from here you can see that my dummy dot next is my new head. So dummy dot next is going to be my new head. And let's have a look at the simple list example that we had a look for the first time. So here, if we follow the same thing, we have our dummy node, and we have our left here, right here. So after we reverse this, so dummy dot next is going to be this node, and this node is not really affected, so that's why it is also the original head of the of our linked list. So for all the cases, dummy dot next is going to be our head of the output linked list. So let's have a look at the code implementation to understand this better. So now let's dive into the code implementation of our function. So we have this reverse between that we need to implement. So here we can start with first writing our dummy node. So here we can have dummy equal to new list node -1. You can set dummy dot next as head, and at the end we have to return dummy dot next, and we can specify the base case as well first. So here, if left is equal to right, then we can simply return head and we will be done. So first what we need to do is we need to iterate over the list, and we have to find the left node and right node references. So here, as you know, the left and right integers, they are just indexes, and we need to find the references. So let's create 4 variables. We're going to need 4 variables. first one would be previous, and let's set by default to null. Let's create left node as null, list node, right node as null, list node next as null. And to iterate over the linked list, since left and right are indexes, we can define a variable called as index as 1, and we have to keep going until we find the right node. So we need to set left and right nodes, and right is greater than equal to left, so we need to keep going till we find the right one. So here, while right is index is less than right, let's say index is less than equal to right. And also, to iterate over the linked list, we are going to need an iterator reference. Let's call it current, let's call it head and set it as head. And in our linked list, we are going to set current as current.next, and we have to keep going. So here we need to set previous left node, and at the end, once we are done with this while loop, we can set our right node. So here right node would be current once we are done with it. So it should be index less than right, because we're doing current equal to current.next and index plus plus. And what we can do for previous is, so previous would be at left minus 1 index. So what we can do is, if index is less than left, we can have is previous equal to previous dot next. And once we reach our index equal to left minus 1, we don't update our previous pointer. And for our left node pointer, we can simply have our check as if index is equal to left. What we can do is set our left node as current, and here we don't have the less than equal to here, because let's try to debug this. So let's say if index is less than right, and we are doing the current equal to current.next, so this is automatically going to reach at the node which has the index equal to right. So that's why we don't have the equality here, and we break out of the loop and we set the right node as current. And we have this, we set the previous, and we set the left node, and we have our right node. So next what we have to do is we have to first set our next pointer. So next pointer here, it's going to be right node dot next, and what we have to do next is we are going to have to set the right node dot next as null. And after this, we can call our reverse list function on left node. So let's implement the reverse list function. So I covered the reversing linked list in previously in the reverse linked list question. So here we have reverse list node head, and can have previous null, list node current equal to head, current is not equal to null, list node next equal to current dot next, current dot next equal to previous equal to current equal to next. At the end, we return previous. So if this piece of code is confusing, please have a look at my old video where I cover reversing the linked list. So here we can call reverse list function, and here it is going to return the new head. So in this case, the new head is going to be our right node, and once we get this, we can set our pointers accordingly. So our previous dot next is going to be our right node, and left node dot next is going to be our next pointer, and at the end you can simply return dummy dot next. So let's try to run this and see if we have any errors. Okay, we have a runtime error. Okay, we have previous. Oh, so we have to set the previous to dummy initially. Okay, it says accepted, which is good. Let's try to submit. All right, that's good. So this code works. And one more thing we can do is, in this reverse list function, instead of having a return type, we can simply do void, and we don't need to return anything, because this is automatically going to set the right node even if we don't explicitly set it here. So let's try to run it. And yeah, this works. So I hope this made sense, and if you have any questions, let me know. And I'm going to cover all the linked list questions here on my YouTube channel. So please like and subscribe, and I'll see you in the next video.